everybody. So this lecture is just explaining basic data analysis and presentation. I'm going to do a two-part series of this specific slideshow lecture. This is available on Sakai. So this is part one. We're going to go over how data analysis works, what kind of variables there are, and how this relates to your most recent lab. So here we go. So scientists need to know how to collect, organize, interpret, and present data. Graphs and statistics reveal trends and lead to predictions of large and/or complex sets of data. Taking big sets of data is basically useless when you're trying to explain it to other people or demonstrate it in a journal if you don't make sense of it via statistics, and graphical analysis is a really great way to condense the information that you collected and easily show it so others can interpret it. So there are two types of variables that we're going to look at today. There's the independent variable. So this is the variable that is controlled by the experimenter. It is what you are able to change. And then there's the dependent variable, which changes as you alter the independent variable. So this is a variable that depends on what you alter. So it depends on kind of the independent variables. So last week, you collected data on species diversity based on tide and location. So you had the Fox Island location and the GSO dock location. What is your independent variable? So what variable did you examine? And what was your dependent variable? What did you measure? So we examined the slides and kind of samples of water from two different locations at two different tides. So we had 4 sets of data, if you will. You had incoming Fox Island, outgoing tide Fox Island, incoming tide GSO dock, and outgoing tide GSO dock. Since we could control when we collected the sample, so incoming tide or outgoing tide, and we could control where we collected the sample, those are our independent variables. Then our dependent variables, so what did we measure? Species richness, species diversity, that is what we were able to measure. So that was our dependent variable. So you're going to be doing summary tables quite often. Most lab reports you'll be writing a summary table, and it needs to include the mean, the standard deviation. It needs to include descriptive labels, as you see here. And it also needs to include a descriptive caption, which includes what is shown. So basically, what data are you pulling from? What was the sample size? So here, the sample size was n equals 6, as you see up here. And you want the descriptive caption placed above the table. So I highly suggest going back and re-looking at this before you submit your lab reports, because your TA will take off points if you don't include the sample size, or if the descriptive caption is in the wrong place, or if you don't include your mean or standard deviation and things like that. What's important about a summary table is that it's a summary. It's kind of how you take your big, large data set and condense it into a small table. So you don't want any raw data in your summary table. You just want these values here. So think before you graph. Graphing is really important to show trends in your data and just really show other people what you collected. But different graphs can kind of show you different things. So you want to understand what you're looking at, what do you want to know, and what do you want to show. So graphing basics, the dependent variable is on the y-axis. So you think of y because it's long, and as you see, this is kind of the vertical line. So for the graph that you're going to do for your first assignment, you're going to have the y-axis being species diversity, because that was your dependent variable. Then on your x-axis is your independent variable, x, because it's kind of like wide. So as you see here, they have the different biomes, so lake, marsh, ocean, river. But for us, we're going to have Fox Island incoming, Fox Island outgoing, Fox Island GSO incoming, and GSO outgoing. And you graph variance using error bars. You've already learned how to use Excel to plot data. So you use error bars to show how your data varies from each other. And these are the error bars here, as you see circled in green. You can also choose to use Boxplots to show variation in data, and you will be doing Boxplots during this semester in R as well. So this bold line here where the red is pointing to is the middle value, the median value. Keep in mind it is not the mean. It is kind of if you put all of the numbers out in order, it is the one in the middle. The top of the box is the median of the top values. The bottom of the box is the median of the bottom values. And these whiskers, as you see here, show the largest and smallest values in the data, and they are not the outliers. And as you see here, these points that are kind of not part of the graph are outliers. So you have the first quartile up here, the second quartile, third quartile, fourth quartile, and the middle 50% are kind of what is inside of the box, if you will. So outliers, again, are represented by points beyond the box and whiskers. An outlier is also defined as a value that falls more than 1.5 times above the third quartile or below the first quartile. And always make sure, again, that when you have a caption on a graph, you need to include your sample size. So n equals, and then whatever your sample size was. When you're presenting your data, always include descriptive axes labels with units. Some of your axes labels will not require units, but if they do, you need to include them. So as you see here, location has to do with lake, river, ocean, marsh, and then diversity is just a set of values. And that should not, since you need to include just with units, you can't just say diversity without a unit, because I bet there are a bunch of different types of units for diversity. So they need to show tick marks. And then you can add a legend here, as you see on the right, and we'll learn how to do legends using R. As you see here, these are color coded. And then place the caption below the graph versus when you have a summary table, you want the caption above. With graphs, you capture them below. And you want to include what was plotted, what the sample size was, and again, it goes below. It doesn't need to be terribly long, maybe just a sentence or two, if that, but you need to include it. We handle data last semester or last year. If you took 103, you primarily use Google Sheets and Excel. Whereas this semester, we're going to be working with R, which is a coding software. And R is great because you tell it exactly what you want it to do. So it can have the capacity to do very complex plots and analysis that you can't do using Google Sheets or Excel. So kind of